Dear students, this is a video part number 1 dealing with limit of a function. So already I have sent you some introductory videos dealing with the concept of limit of a function. In plus 2, as you have been introduced to this concept, we will quickly revise the definitions and properties, and we'll do some problems. This is what I intend in this video. First, we'll have formal definition. That's also called epsilon delta definition of limit. Epsilon delta definition. Epsilon delta definition. Now, formal definition goes like this. Let f of x be defined on an open interval about a number x0, where we will be finding the limit. So f of x is defined on an open interval about x0, except possibly at x0. May be defined or may not be defined. That's why except possibly at x0 itself. We say f of x approaches the limit as the real number L. So limit, remember, it's a real number, as x approaches x0. So f of x will approach the value L when x approaches to this x0, and we write this well-known notation, limit of f of x as x tends to 0 as L, if for every epsilon greater than 0, there exists a corresponding number delta greater than 0, such that whenever this inequality, means whenever x lies between, so x is having a distance less than delta, then f of x will be having a distance less than epsilon from L. So for all x satisfying this inequality, this will. So this is a game. It means given epsilon greater than 0, you will be able to find delta depending upon that epsilon sometimes, or sometimes independent about epsilon. So will be uniform continuity, etc. You will be learning later. Anyhow, this is definition of a limit, formal definition of a limit. Okay, you have to take the note of this definition. Once again, this happens only when we talk about limit x tends to x0. So this, whenever epsilon, first of all, epsilon will be given. Corresponding to epsilon, we can find a delta. Delta is about x-axis, and epsilon is about y-axis. So epsilon distance of f of x from L, and delta distance from x0 x0. That's the thing. Now, important rules of limits. These are all familiar to you. Whenever you have a function f of x is equal to x, then limit of x as x tends to 0 will be x0, and limit of a constant is always the same constant. So these two important limits you have to learn. Now, proof for the first one, you take epsilon greater than 0, you have to find a delta. Here delta can be taken as epsilon itself, because here f of x is x itself. Therefore, instead of f of x, here is f of. So x minus x0 is delta, means f of x, which is x, same as x0. So here we can choose delta equals epsilon. So here the required value of epsilon is same as that delta. So required value of delta is same as the given epsilon. So the proof is simple. Now in the case of f of x equal to k, means you are finding limit of a constant. That's always a constant itself. So given epsilon greater than 0, what is that value of delta? That means you should have, what is f of x here? K. So k minus limit is also k. So k minus k is always 0. 0 less than epsilon is always true, because epsilon is greater than 0. Therefore, for any delta, this is true. So for any we use any positive delta for this implication will be true. Therefore, here the limit is always k, and here the limit is always the point selected, which is here it is x0. So that's the first two theorems you have to remember. Now other rules, which we call as sum rule, difference rule, product rule, constant multiple rule, quotient rule, and power rule. When you add two functions, and if you can separately find the limit as L and M, you have to add limit of f of x plus limit of. So it is just like this. Limit of sum of two functions is same as sum of two limits. That's what we call as sum rule. Similarly, difference is difference rule, L minus M. Product means it is L into M. And if you have a function multiplied by a constant, that constant comes outside the limit, and k into limit for any k, whether it is 0 or non-zero, it's 0. But here in the case of quotient, you must be very careful. The denominator limit of g of x must be different from 0. So limit of the quotient is equal to quotient of the limit, provided limit of the quotient is the denominator is not equal to 0. So if we have m and n are integers, then if we have a function like this f of x all raised to m by n, then you can simply apply limit to the function f of x. That will be L, so L raised to mn. These are the limits which you know very well. These are the properties which you know very well. Now, in the case of polynomial, suppose you have a function which is a polynomial, a0 x raised to an x raised to n plus an minus 1, like this, a polynomial. Then in order to find a value of this limit when x tends to 0, you just simply substitute x as a c. Therefore, you'll be getting it as p of c, that is a0 c raised to n plus an minus 1 c raised to n minus 1 plus extra plus a0. So in the case of polynomial, you can see that the value can be evaluated, the limit can be evaluated by replacing x as c. There is no problem at all here. In the case of a rational function, limit of this is what we call as px by qx is what we call it as rational functions when p of x and q of x are polynomials. Then you just replace x by c, that is p of c by q of c, when the value is, we are calculating x tends to c, when the limit is calculated using x tends to c. Okay. Now sandwich theorem, this is where you have to focus for the examination point of view. Some questions may be asked in sandwich theorem. This is sandwich theorem. So if we have three functions, f of x, g of x as well as h of x, satisfying this condition, g of x is less than or equal to f of x, less than or equal to h of x, for all x in some open interval containing c, except possibly at x equal to c, then whenever these two limits are same, right, limit of f of x as x tends to c, and limit of g of x as x tends to c, and limit of h of x as, if they are same, then f of x cannot go somewhere else. It should also have the same limit. So if f of x is sandwiched, that is f of x lies in between g of x and h of x, and if this goes to these two things are going to the same value L, then f of x also should have the same value L, same limit. That is what we call as sandwich theorem. Now this is another theorem, not like that of sandwich theorem. If you have an inequality, only two functions, f of x is less than or equal to g of x, for all x in some open interval containing c, except possibly at x equal to c, then limit of f of g, both the limits should exist, then the inequality is carried over to the limit also. Means the limit of this f of x must be less than or equal to limit of g of x. This is another useful theorem. Okay. Now we will have some problems. This is very important as far as the examination point of view is concerned. Suppose you have an inequality like this. You have a function u of x which is sandwiched in between 1 minus x square by 2 and 1 plus x square by 2 for all x not equal to 0. That means this is true for all x not equal to 0. Now the question is, what is the limit of u of x as x tends to 0? What is this? You could take this as f of x and this as g of x. What is limit of this function when x tends to 0? You can see it is 1 because this is 0. And limit of g of x as x tends to 0, limit of this one as x tends to 0, you can see this is also 0. Therefore, u of x is sandwiched in between these and two, whose limit is same as 1. Therefore, limit of u of x must also be 1. This is the application of sandwich theorem. That is the first goal. Second theorem is another important result. Suppose we have limit of modulus of a function is 0, then limit of the function without modulus also must be 0. So here we will be using a very important mathematical inequality. For any number a, we can have minus a less than or equal to minus modulus of a less than or equal to a less than or equal to modulus of a. This is applied quite often in mathematics. Therefore, if you take a as the f of x, you will be saying that minus modulus of f of x less than or equal to f of x less than or equal to modulus of f of x. Therefore, this f of x is sandwiched between this and this and this. Here the limit of this one is 0, this one is also 0. So using sandwich theorem, you can see that limit of f of x is equal to 0. That is another application. Now these are the homeworks which you can do. First one, if f of x is sandwiched in between root of 5 minus 2x square and root of 5 minus x square. What is the value of limit of f of x as x tends 0? It's quite simple. You will be getting an answer as 0, root 5, because here it is 0, here is also 0. So the value of the limit will be root 5 less than or equal to limit less than or equal to root 5. Therefore, you will be getting the value of this limit as root 5. The second question and third question you can read and pause the video and take down the work, and you can take them as homework. Everything is easy, but for the examination point of view, they are very important. Now, some additional problems. These are all questions which you might have done in your plus 2 classes. Suppose you have a limit of a function like this, which is involving a variable h. This is f of h. The variable here is h. Now the question is how to find h tends 0. When h tends 0, you can see that denominator is 0. Numerator is also root 2 plus 0 minus root 2, which is 0. So 0 by 0 form. So we have to rationalize this one by multiplying with the conjugate. What is the conjugate of root 2 plus h minus root 2? Which is root 2 plus h plus root 2. So after a minus b and a plus b is same as a square minus b square. Applying that and simplifying this problem, you have to complete it, because it is so you will have to see after cancellation. You can see that this 2 plus h minus 2 will be cancelled with this 2 minus 2, h by h will be cancelled. That will be getting 1 by root of 2 plus h plus root 2. Now you can put h as 0. It is 1 by root 2 plus 1 by root 2, which is 1 by 2 root 2. So such problems you can expect. So this is another homework which you have to do using the problem which we have just done. You have to apply, rationalize it. It means you have to multiply with 2 plus root of x square minus 5 on both numerator and denominator, and make cancellation, and finally you will get a number. This is another one. Here you have to multiply both numerator and denominator by 5 plus root of x square plus 9. Okay, so that's all in this video. Thank you for watching. If you have any doubt, you can ask.